Hello, everyone, and welcome to the National Stock Assessment Science Seminar. My name is Bailey, and I coordinate this monthly seminar series that highlights interesting advances and topics in stock assessment science. Today, we are really excited to have Dr. Cassidy Peterson and Dr. John Walter with us. Cassidy is the Management Strategy Evaluation Specialist for the Southeast Fisheries Science Center. Her research interests center around the use of MSE in the Southeast, developing implementable management approaches that meet manager and stakeholder-defined objectives. John is the Deputy Director for Science and Council Services at the Southeast Fisheries Science Center. He has 18 years of experience conducting stock assessments and providing management advice to regional councils and intergovernmental fishery organizations. In today's seminar, they will present and debunk the myths that hinder successful application of MSE. Without further ado, I will turn it over to Cassidy. And thank you all for joining us.
So thank you all for having us here to present the myths of MSE. And before I continue, I do want to recognize that this is foundational work that was conducted by the NIMFS MSE working group, which consists of all of the MSE specialists in all the different regions. And so I list them here as co-authors on this work. And I'll start by offering a friendly refresher on management strategy evaluation, which is a process designed to develop and stress test management procedures, making sure that they're robust to uncertainty. As Andre Punt and colleagues' best practices guidelines dictate, there's 5 steps to conducting an MSE. The first is to identify fishery-specific, stakeholder-defined management objectives, and these are management objectives that should be reflective of what the stakeholders want to get out of the fishery, and they should also include consideration of legal Magnuson-Stevens mandated fisheries management goals. Step 2 is to identify relevant uncertainties over which the management procedure should be robust. I think it's no surprise that we don't know everything about our marine ecosystems, and we certainly don't know enough to accurately abstract them into simulation dynamics models. So characterizing uncertainties is a key step. We then use those uncertainties to develop our suite or grid of operating models. Our operating models are sort of simulated truth, and they represent different hypotheses of the underlying dynamics of the resource. And if you can see on this diagram, the operating model up on the top is sort of nested to reflect that we've developed multiple operating models, each reflecting sort of the suite of uncertainty we could experience. So hopefully our operating model grid really envelops the plausible states of nature that we would expect for a given fishery. Step 4 is to identify management procedures that are responsive to stock dynamics. So in this graphic, everything highlighted in green is part of the management procedure as it's strictly defined. So that includes a description of the data generating processes as well as the quality of those data. It includes the estimating model, which is sort of broadly defined as the way that we analyze those data that we've obtained from the data generating process. It could potentially include a stock assessment model or simpler approaches. The results from the estimating model component are then fed into a catch control rule or a harvest control rule. And this is the adaptive management piece. So it specifies how we should adjust management recommendations based on our perceived state of the stock. And then those management recommendations from the catch control rule are implemented back into the fishery. This feedback loop is important. It's what characterizes the management strategy evaluation from any other type of simulation analysis. And that leads us to step 5, which is to simulate this entire loop iteratively multiple times into the future so that we can characterize how these management procedures will perform in a bunch of different operating model scenarios. And then we summarize and present the results using performance metrics that are calculated from the operating models. And performance metrics are really carefully constructed to reflect the fishery-specific and stakeholder-defined management objectives that we defined in step 1. So we're really taking care with MSE to develop management approaches that reflect the needs of the stakeholders. Some key definitions: we already talked about management objectives, which are the goals of the fishery, the operating models, which are the simulated dynamics of the system within which MPs are tested, and management procedures, which are those pre-agreed on frameworks for setting management recommendations, and they're designed to achieve management objectives. So essentially, a management procedure is sort of a recipe that characterizes how we should manage and set annual catch limits. We can categorize management procedures into 2 different categories based on whether or not they employ a population dynamics model. So as the title indicates, model-based management procedures use a population dynamics model and use that to estimate stock status and provide management advice. So a traditional stock assessment could serve as the estimation model for a model-based management procedure. Empirical management procedures, on the other hand, have no population dynamics model to describe the underlying dynamics. Instead, these are often referred to as indicator-based approaches because they rely on an indicator of relative abundance and adjust the behavior of the management recommendation based on the behavior of that indicator of abundance. So as sort of the national MSE specialists throughout NIMFS, we've had a lot of experience trying to implement MSEs, making sure that these results are key within the and functional within the U.S. fisheries management process. But we've received a lot of hesitation, understandably, because it's really scary to completely shift from one management regime into another. And this slide sort of shows some of the feedback that we hear, and we're characterizing a lot of this feedback as the myths. There's some misunderstanding of what characterizes an MSE, like if there's no stakeholder participation, it doesn't count. MSEs always are much too resource expensive to actually conduct in a reasonable time frame. There's some misunderstanding about how MSEs are related to stock assessments. So we've invested a lot into our highly sophisticated and highly complex stock assessment enterprise. So why would we throw that out when we have our stock assessments that work to manage our fisheries? We can't manage with management procedures that don't provide stock status. We can't use a management procedure if a stock is in a rebuilding plan. And our regulatory process isn't fast enough to really implement management procedures as the pre-agreed upon recipe that they're designed to follow. But these are myths, and hopefully throughout the course of this presentation will help to debunk some of these common myths. The first clarification that's most important is that MSEs don't replace stock assessments. If you think about fisheries management, we can really break it down into 3 different questions, which is where are we now, where do we want to go, and how do we get there? And for complete and holistic resource management, we really need to address each one of these questions. Stock assessments are certainly the best tool to answer the question, where are we now? But maybe they're not necessarily the best tool to answer the questions, where are we going and how do we get there? And that's where management strategy evaluation and management procedures come into the equation. So this is a complete toolbox that we can use to manage fisheries. We also want to distinguish stock assessments from the management procedure approach. So I assume we're all very familiar with the conventional stock assessment process, where we collect a bunch of data, configure stock assessment models, run the assessment and forecasts, make sure it's best available science, and use that to get management recommendations. However, the problem with this, as sort of characterized in Dan Gaithel and colleagues' 2018 paper entitled "The Stock Assessment Total Allowable Catch Treadmill," is that each step opens the door for a lot of deliberation among all of the different user groups. And this can sometimes lead to stalled action, which, as we have seen, can adversely impact the way that we manage our fisheries. So, within the conventional stock assessment approach, there is deliberation between stakeholders, managers, and scientists on what data we should include in the assessment, how we should configure the stock assessment model, and how we should parameterize it, how we should characterize the forecast, and what biological reference point we should use, and ultimately, some deliberation on what is the appropriate management to implement for a different stock. The MP approach is designed to really streamline this process for increased efficiency. So, again, the MP approach is the process of managing with an MSE tested management procedure, and the management procedure, as it's designed, should be fully specified and it should be automated as a recipe. So, the MP automatically collects data as it's specified to do within the recipe, automatically run the recipe to get management advice, which is then implemented in the fishery. This doesn't eliminate the opportunity for stakeholders and managers to provide feedback on the process. Instead, all of that feedback is front-loaded when these management procedures are stress tested within an MSE. When a full stakeholder MSE is undertaken, stakeholders and managers are iteratively engaged from the very beginning of the management strategy evaluation, and they are sort of co-owners of the management procedure that's ultimately developed. This figure really demonstrates the benefits of managing with a fully specified MSE tested management procedure. So on the left, we can see sort of the management process when we're using untested or partially specified management procedures. So this is a management procedure that has not gone through MSE testing. Maybe it's not automated. Maybe we've only MSE tested part of the management procedure, like just the harvest control rule, for example. And so each management cycle, we reopen the door for a lot of controversial negotiations. We're thinking about objectives in the short term, and we're not considering mid or longer term performance and how that's related back to our management objectives. And our management objectives aren't codified. Participants are allowed to comment on the process, but they're not really engaged as co-owners of the process from the very beginning. So there's potential for them to feel like they're not fully engaged or that they're tangential to the process. The science is a little bit more uncertain because there's not a structured framework to incorporate uncertainty in the way that there is in a management strategy evaluation. So we do sensitivity runs, but we're not specifically looking at the impact of uncertainty on management performance, and that's the focus of MSEs. Lastly, performance is relatively unknown because outcomes are not linked back to management objectives that are specified by our stakeholders and managers. And we're also looking, again, at very short timeframes. On the contrary, with fully specified management procedures that are automated and they're fully MSE tested, we have an agreed upon approach where all parties are working together and identifying the best way to maximize our ability to achieve management objectives. Participants are really central to the entire process, again, iteratively engaged. They have a sense of ownership, and this leads to a sense of buy-in into the resulting management. Uncertainties are formally addressed in our operating model grid and in our management implementation. And again, we have codified performance metrics that are coming from management objectives that we have officially agreed upon as scientists, stakeholders, and managers. Institutional inertia has really solidified this idea that conventional stock assessment is the basis for determining management advice. So we do a stock assessment and we use that stock assessment to provision management advice. However, there's actually no requirement that stock status be updated annually or with any predetermined frequency. We need annual catch limits every year, but they don't have to be based off of an updated stock assessment. There's also no requirement that fishes must be managed using a model-based approach. So ultimately, empirical and other data-limited management procedures can be legally applied. And often this is the case, like the short fin squid that's pictured here. So essentially, we recommend decoupling the provisioning of stocks of management advice from stock status determination. We think of them as linked because that's what we've often done, but they don't have to be. And some of the feedback that we get is that council process is too slow to sort of run a management procedure and update it every year or with sufficient frequency. But essentially, if we have fully specified management procedures as recipes that can be automated, they can be implemented as closed framework actions or something similar. So this is something that can legally be applied within our council framework. Often we're also under the assumption that it's really scary to transition to a new management regime, and it feels a lot like jumping off a cliff. But we build in a lot of safeguards to make sure that we're not jumping off a cliff or that we have a parachute or a ladder or something on our way. Some options for these safeguards are phased in management procedures. So you can put sort of guardrails in your management procedure so that in the first few years, that transition is really slow and gradual. This is something that can be built into your management procedures and simulation tested within the management strategy evaluation. Most importantly, we build exceptional circumstances protocols. And so exceptional circumstances detail scenarios where the true dynamics are not what we simulation tested within the management strategy evaluation. And this is grounds for overruling the management procedure and applying some sort of backup management action. This figure on the right is sort of a demonstration of exceptional circumstances protocols for Atlantic bluefin tuna. And so this plot shows Atlantic bluefin tuna indices of relative abundance that are used as the basis of an empirical management procedure. The purple shading sort of describes the distribution of indices of abundance that were simulation tested within the MSE. And the blue bars on the top and bottom are the 95th percentiles. And basically, we feel very confident that we know how the management procedure will respond if the true index is within this 95% interval. If the true observed index, which is characterized by these solid black lines, falls outside of this range, then that constitutes a breach because we're not confident in our ability to understand how the management procedure will perform because we didn't simulation test for that. It's then a scientific exercise to measure the breach of exceptional circumstances and to determine what additional action needs to occur. One action that could occur as a result of exceptional circumstances is to trigger an MSE review or a management procedure review. These should all be regularly scheduled on the order of every 7 years or so. And basically, these are opportunities to consider all of the additional information that has been gathered between now and the last review or now and the last MSE conditioning to reconsider the list of operating models that are within your operating model grid. Consider if some of them are now proven to be implausible or impossible. If we have new scenarios that we need to include, we can build those in, and then we can parameterize the management procedure to make sure that it's still maximizing management objectives. And so these are already regularly scheduled to occur. So we're constantly checking up on the management procedure to making sure it's working for us. And lastly, we still conduct regular stock assessments. We still need stock assessments as health checks if they're not already included in the management procedure. So again, this is that holistic management. We still need to make sure the stock is healthy. Magnuson-Stevens and National Standard Guidelines mandate that we manage for optimum yield, which is defined as the yield that provides the greatest overall benefit to the nation. It's equal to maximum sustainable yield as reduced by relevant biological, economic, social, and ecological considerations. But it has to be less than or equal to maximum sustainable yield. And we know that there are a variety of fisheries, particularly those with high recreational importance, like dolphin fish, that's pictured here, where maximum sustainable yield might not actually be optimum yield. It might not maximize all of the management objectives for the stock. Secondarily, we also know that maximum sustainable yield is a moving target. If the fishery configuration changes and selectivity changes, then maximum sustainable yield is going to change. So, optimum yield, instead of being something that we can sort of analytically calculate, is really a product of all of the goals of the fishery and how we can sort of configure the fishery in a way that's going to provide greatest benefit to the nation. And MSE is really designed to address optimum yield. And so we suggest that it be a key player when attempting to manage for optimum yield and identifying optimum yield. And ultimately, MSEs or management procedures are simulation tested to perform. So if a management procedure has been shown through simulation testing to perform in the face of existing or future uncertainties, it should be considered robust. If it's been shown to be robust to future non-stationarity, it should be considered future ready. If it's been shown to rebuild an overfished stock, it should be considered valid as a rebuilding plan, and if it meets MSA must meet criteria, it's consistent with Magnuson-Stevens. It's also a key tool for ecosystem-based fisheries management. We want to clarify that robust doesn't necessarily equate to precautionary. Robust is showing that the management procedure can respond in the face of uncertainty, whereas precautionary is making sure that it can perform with greater risk tolerance. So they do reflect two different concepts. And to clarify that, there's maybe not too many, one comment that we hear is that there's too many uncertainties to actually do an MSE because the operating model grid would just blow out of control. And key uncertainties can be appointed to a main reference operating model grid. These are the most important uncertainties that are used to parameterize the management procedure. And sort of sensitivity or secondary uncertainties can be characterized in a in a robustness grid. And this is just sensitivity testing the management procedure. Additionally, many axes of uncertainty don't necessarily change management performance. Maybe they're important to characterize the dynamics of the fishery, but they don't actually change the way we would manage. And when that's the case, those uncertainties can actually be dropped from the reference operating model grid. And as a demonstration, I have northern swordfish pictured here, which underwent an MSE where the initial operating model grid was over 200 models. And ultimately, once it was culled for axes of uncertainty that were not important, the ending operating model grid is 9. And now I will go ahead and pass it off to John.
All right. Good afternoon or good morning, everybody. Thanks for allowing us to be on here to talk about MSE and some particular aspects of it. I'm John Walter, Deputy Director for Science and Council Services. And so the second half of this, or the other part of it, is going to talk a little bit about some of the particular topics of MSE that we've gleaned after many years of actually conducting them. And I think one of the things that isn't as well recognized and really needs to be is who's who in the ecosystem of MSEs. And in particular, identifying the roles, responsibilities, and sometimes the prerogatives of people who are part of it. And so scientists, which are many of us probably on the call, are actually paid to do these. So this is our job. And I think one of the things we have to recognize is that we're definitely have the benefit of being able to be paid for it, and that others may not. And managers are another key component of it. They're usually the ones who are paid to be part of it or appointed if they're a council member. They bear the responsibility for the decision making and implementing what is an inherently a political decision regarding the allocation of scarce resources, in most cases that we're working on fish. Now, there's also a lot of people involved in these who are advocates, often are professional and paid representatives of NGOs, fishermen, or other groups, and they may not actually suffer the same opportunity costs for meeting participation. They may even actually be motivated to have more and more meetings. And one of the key things that we've found from doing these MSEs is that the meetings can often become interminable. And unless you are conscious about keeping time to them and being conscious of other people's time, they can take a much longer time than they really need to. And the focus really, I think, needs to be on understanding who the true stakeholders are. These are the people who are most affected by the management decision, and they're ones who bear the greatest opportunity cost for participation. They're the ones who have another job. They are fishing. They are dealing fish. They are processing. They're generally not paid to be here, but they're the ones whose time is the most valuable in terms of getting the information about what stakeholders truly want. Next slide. And so I think one of the key things we've been trying to understand is how much stakeholder participation is necessary. And here we've put a continuum of stakeholder participation across ranging from the full stakeholder MSE, which can be multiple years. It is quite intensive, to things that are desk intermediate MSEs that might have some intermediate participation, desk MSEs that can be done by just a single analyst on a desk, and then a lot of things that are not MSEs but look something similar, such as simple simulation exercises where there's no full feedback loop. And the key distinction across those degrees is how much of the conceptual and operational management objectives are already codified. If they need to be developed, that is a strong argument for a full stakeholder MSE. If they're already well known and codified, then in fact a desk MSE can optimize different management procedures and test them across known management objectives. And so finding out whether those objectives are already known really tells you where you need to be on that spectrum of intensity. And then there's a lot of times we're asked to do things such as harvest control rules, where the operational management objectives are pretty well codified. The harvest control rule is just how you adjust the catch. These are actually quite simple and could range either from intermediate to desk MSEs, depending on what other conceptual operational management objectives might be considered by stakeholders. And in that case, there are often things that are not actually addressed by, and I'll go into the next slides on some of those things and the reasons we might want a full stakeholder MSE. And I think I prioritize the highest for adopting binding management advice. When it counts, when that advice is going to matter, that would be a situation to invoke the full range of stakeholders. When there's a really difficult policy decision, these are the wicked problems, to quote John Hare. There's when the situation and the answer is not clear, and when you need stakeholders to be able to codify their operational and conceptual and operational management objectives, and the solution is going to be a compromise across those objectives. In situations where there's heretofore intractable stakeholder conflicts, that's when MSE can bring people together. They can see the trade-off and they can see the compromise space that always existed in every decision. They just may not have actually seen the trade-off written down. And then when there are disenfranchised stakeholders, when stakeholders who are not part of the process need to be brought into it. And we actually, in a paper here, when to conduct and when not to conduct MSE, we talk about one of the disenfranchised stakeholders is often the ecosystem components of the system who may not be part of a traditional single species fisheries management decision. There's also a large number of other stakeholders who are probably not party to the traditional fishery management decision-making process, but have a stake in the outcome. And then when the scientific uncertainty threatens the integrity of the current management approach, or when the status quo management is clearly failing, these are the known unknowns. We know what's happening, we don't know why it's happening, or the management is not working, and that we need to bring in the power of stakeholder ideas to be able to develop management procedures to be able to find a way to robustly manage our way through that. And then when there are situations where the future is really unclear, the unknown situations, and really environmental non-stationarity, climate change, whatever you call that, is really one of those unknown unknowns where we know it challenges our traditional stock assessment process. We know it's going to challenge our fishery management, but we can develop scenarios for what the future might look like and then evaluate whether different management approaches work under certain scenarios. And then more importantly, we can identify when they fail so we can build in checks and balances in the exceptional circumstances provisions that Cassidy went over so that we'd be able to say, here's what we do when things fail. And I think in that case, that's the best we can provide decision makers who otherwise would have to rely simply on our projections of stock assessments. They wouldn't necessarily even know that when something, the things to look out for, those failure points. And I think that's a key to being able to say what is a robust or climate resilient management approach. Next slide. Simpler situations where less intensive approaches may suffice, particularly to develop an empirical management procedure that might improve upon the status quo. Empirical management procedures or index-based management procedures are relatively straightforward, and that usually they are easy to explain. When an index goes up, the TAC goes up. When the index goes down, the TAC goes down. And in a number of simulations, we've actually found that it works quite well, particularly when there is environmental non-stationarity, that our traditional stock assessment models would generally not be able to pick up when it happens at rapid timescales. And then to modify or adopt a catch control rule when time and resources are limited. And a lot of times, a pretty good harvest control rule or catch control rule is better than nothing. In fact, in most cases, it's better than nothing. And so if the goal is just simply to get a harvest control rule in the interim, don't take 5 years to run a complicated MSE. Develop something in a relatively simple framework and implement it. And then mainly tactical decisions regarding allocation of survey or scientific resources. These often can be done with desk MSEs. And another situation where often the MSEs at many of the international regional fishery management organizations, usually the tuna RFMOs, are desiring MSEs to implement management procedures for certifications. In those situations, there is an external purpose for that, and they're utilizing the resources of that RFMO or national scientist to do that. In that case, understand, again, remember the ecosystem of players. If an external group wants that, an external group should be helped to support the process, both financially and in other resource ways. And oftentimes, when many of those external stakeholders have materially supported the process in many of the MSEs we've done. And then when there's research or scientific questions not intended to directly support management advice, MSE is an excellent tool simply for the stock assessment scientist to be able to evaluate how do I model this and which is a better approach for modeling something. Those can be done with desk MSEs. Next slide. And we gave a presentation a couple of weeks ago on stakeholder disengagement. And it was somewhat controversial in the sense that so many papers have talked about including stakeholders. We've often said they're an integral and essential to the process, but they're also the ones that have a lot to lose in it. And I think the key here is being kind to your stakeholders, understanding that their time is exceptionally valuable for us and it's a precious resource. And we should focus it upon the highest profile, paradigm changing and management decision based applications. So we as scientists or as managers need to be kind to them, high grade their participation, and avoid unnecessary situations or material that is not germane to the decision at hand. So some of the lessons that we've learned, one, show, don't tell results. We can talk all we want, but until somebody sees something on a screen, it doesn't matter. Distill the material and the presentation down to the key decision points. Avoid unnecessary material. And it's challenging to do that because we want to convey a lot of information. But unless there's a decision there, it's probably not that important. Listen, build in what stakeholders want, and test it. So when they say something or come up with an idea, do not dismiss it. Let performance be the answer. If it works, great. If it doesn't, performance will show that. C number 1. Enforce data guillotines. Don't let perfect be the enemy of the good. Again, our time is so valuable. We need to enforce those so that we can make progress and move on. Be comprehensive, and every participant has their finger on the trigger of no. Use ambassadors, who are people who can be intermediaries. They're trusted members of the community. They're ones who can engage in the process, but then explain it to many of the stakeholders who might not have the time to be able to engage as fully. Speak in the language people understand. Literally, if you're working across international borders where people are speaking different languages, translate the material, interpret it, and then have conversations in the language with interpreters so that people can understand and respond back in their language that they are comfortable in. And then make it count. Use real numbers, real tax, and make it matter to decision makers. We found that with many of the tuna RFMO commissioners, the ones really deciding, anything we said didn't matter till we put TAC numbers on the table. Once there were TAC numbers and they knew that this was going to be binding advice, they asked us for more meetings. Once they're asking for meetings, you've got their attention, they understand it, and they're going to keep asking more questions until they get all of the information they need to make a real decision. And oftentimes those real decisions are difficult because they involve making real compromises, which is what we are asking them to do. And then employ the intermediary groups, which is really an essential process to being able to bridge the different components of the MSE ecosystem. So some of the other lessons: focus on MP performance. Performance is what matters. Subjectivity doesn't matter. It is the hard numbers and hard performance that matters on whether an MP is better than another. Always try to run the status quo MP, because really all you need to do is beat the status quo to be doing better than you would with a new MP. Then tailor the MSE complexity to each research question. Don't be more complicated than you need. That's essentially the idea behind all modeling and the parsimony of modeling and the MICE framework. And then find early on-ramps to council involvement or commission involvement. Engage them early. Try to develop an advisory body so that they can form perhaps that intermediary group. And then something that is also often necessary is decoupling the stock status determination from the provision of management advice. Our stock assessments are very good at getting stock status determination. They may or may not be so great at getting absolute quantitative catch advice. They're good at the relatives. They're not as good at the absolutes. And more importantly, they're often several years late, and it's very difficult for us to update them in time for things that might change on the water. And then understand manager risk tolerance. But the only way you get to risk tolerance is, we've asked that. Do you want 60%, 70% probability of meeting objectives? The only time you get someone who's a real decision maker to write down their risk tolerance is to show them the trade-off, and then they can say, okay, I can live with this. And that's where show, don't tell is so critical. I think that's it. Both Cassidy and I want to acknowledge many of our ICAT colleagues who've worked on and been the ambassadors for many MSEs that have been done. Our national MSE technical working group has been excellent to work a lot of these ideas through. Our NIMS colleagues who've often helped us with these MSEs and are integral to the process. Many of our academic partners. And then we've had substantial support from harveststrategies.org. And thanks. Happy to take further questions.
Okay, we did have a question come in. I was hoping for more myths. Any summary on the biggest one?
Probably the biggest myth is that it's going to get rid of stock assessments. And at least from the community of scientists who we work with. And one of the biggest concerns of stakeholders is, well, what about the stock assessment? And so in particular, in specifying the exceptional circumstances provisions and then usually the timeline for how things are going to happen, there's always built in and can be built in a time frame for updating stock assessments for health checks or status assessments, and that they don't, because the MSE or an empirical management procedure may or may not provide stock status, and you may or may not know whether it's working or not. And so this stock assessment can be quite valuable as that check on whether the management procedure is working. But ideally, it would be on a much more reduced time frame, and it wouldn't have as much of the, shall we say, as Cassidy well went into, the added baggage of stock assessments that make squeezing management quantitative TAC advice out of a stock assessment somewhat challenging, somewhat subjective, and often open to a whole lot of political debate. Cassidy, we've got a few more myths too, right?
We do, and I'll also state that we are working on a document that sort of compiles all of the myths, but some of them are, distinguishing between a fishery management plan and a management procedure. The myth that they're both the same, the myth that management procedures are illegal and don't meet Magnuson-Stevens guidance, which we know isn't true. MSEs require stakeholder input to be considered in MSE. We can't update regular annual catch limit management advice without a framework action. The automatic recipe approach removes the opportunity for stakeholder constituents to provide commentary on the process. MSEs would allow optimum yield to be greater than allowable biological catch. MPs don't meet the requirements of a building plan. Stock assessment-based status determination is required as a precursor to management implementation. Empirical MPs are illegal. MPs, like John said, will replace stock assessments. We can't switch to a new regime. The definition between robust and precautionary, and we can't adequately characterize all uncertainties within the MSE. A management procedure abandons reference points. Management procedures and MSEs require mechanistic linkages to environmental considerations to be considered robust and non-stationarity or future ready. MSE is not compatible with EBFM, and that MPs don't meet national standard guidelines.
I'll just comment on one in particular that a management procedure would go over the ABC and allow for catches to be above an ABC, which is a key concern from a Magnuson standpoint. And one of the things that MSE allows us to evaluate are things where, like, for instance, the allocation between two different user groups might actually change the overall MSY. And so under a fixed allocation, your MSY would be conditional on that. Whereas if you open the door to changing allocations across competing user groups, which is directly addressing a stakeholder conflict, you might find that because those user groups have other different objectives, that you could find a MSY that's higher than the one on the books, because a certain user group is saying, I'll take a different allocation because I'm getting something else in return. And a great example that we're trying to get through is something like exploring the optimum yield solution space for between like commercial and recreational fishers who have different competing objectives. They both want fish, but some might want opportunity, some might want yield and stability, and that there might be a trade-off space where they can live with between them. And there might actually be a higher MSY because you've actually looked through that solution space. And one thing I'll also kind of land on there and end on that is that I don't think that optimum yield is going to be something that we solve for with equations. It's going to be something that we compromise on across multiple competing priorities. MSE allows us to find that compromise space. Thanks.
Our next question is, can you elaborate on decoupling stock status determinations from management advice?
So management advice, and particularly the thing that's doing the lifting, is the annual catch limit or the total allowable catch. The stock status is okay, that's what the status is, but what's happening to either rebuild stock status or maintain it or achieve yield is, at least in U.S. fisheries, annual catch limits, and many international fisheries, it's total allowable catch. That's the operational end, the pointy end of the stick for management advice. So in terms of decoupling it, there's some stocks where we haven't changed the stock status in years, yet we have an annual catch limit, and that may or may not have changed in years. And what we're hearing from a lot of our stakeholders is that our annual catch limits being too static, they're not responding to what might be going on. We can't update our stock assessments in a real-time fashion to be responsive to it. But if we could probably better achieve their needs, have a catch limit that is more responsive to what's going on. That's the decoupling of stock status determination and annual or biannual or every 3-year management advice.
Our next question, really interesting presentation, thanks. How would you respond to the stance that a stock needs an updated stock assessment before commencing an MSE process?
I would ask why, and the question being that almost all of the work that goes into developing an MSE is probably the equivalent of, if not a lot greater than, doing a stock assessment, just not without turning the crank to turn it into management advice. So you've got most of the makings of it, you've got most of the uncertainties, and you're probably getting a more of the need for, or the more of the you're testing actual management. So you probably get most of it along the way, but for using it for management advice, you could plan an intermediate step of, say, evaluating status across the operating models, which is not too incongruous with using the grid approach that we ordinarily use for and many of the RFMOs for status determination using traditional stock assessments.
Our next question, I was surprised to see that a regular assessment updates are still done. Is the goal just to stretch the update interval not so frequent? Otherwise, this just seems like more work on top of the assessment update.
Yes, the goal would be to stretch that update interval as long as stakeholders would allow. That is part of the reason for the myth that there's we didn't we haven't been able to get away from having both still there. But doing a stock assessment to get stock status is a lot easier than turning a stock assessment into getting catch advice. You don't have to do projections, and you don't have to make really strong assumptions about what recruitment's going to be in the future. So it's a lower bar. It's probably more suited for what our stock assessments can do in terms of giving relative status advice, be it or BMSYF or FMSY or a proxy, than trying to force them to get total abundance multiplied by an FMSY, which is normally what we do. Problem being, if you look at the Ralston paper about how often we're wrong on total biomass, we're about 40% wrong on total biomass levels each time we update a stock assessment, because it's not that good at getting the total abundance. So we're really trying to squeeze a lot more, I think, out of our stock assessments than the data is allowing us to do.
Our next question is, have you encountered the situation where an MP had to be abandoned because an updated assessment rocked your world and the OMs no longer applied? If so, what happened?
Presumably, that would be an exceptional circumstance situation where the sum total of information is telling you that your stock is not in a state that was previously explored or considered in the development of the MP. I have not. Cassidy, have you?
No, no. MSCs are still comparatively new in the US, I'll say, compared to other countries, and other countries have experienced that and published on it, specifically South Africa and Australia, and they have provided some good guidance on how they went back to a management procedure and management strategy evaluation review to update their operating models, update their management procedures due to exceptional circumstance provisions.
Stay tuned for Atlantic bluefin tuna, as a close-kin marker capture study does inform on the greatest axis of uncertainty, which is the scale of the population. But given the framework that's built around that, what it might do is just reduce some of those axes of uncertainty such that the existing management procedure could be tuned according to a different set of weighting criteria or fit to something else like an external estimate of abundance. I think but certainly it's a good question. I'd like to hear about other ones where that's happened. I think the other myth that we didn't go into is that a management procedure is a 30-year set it and forget it kind of thing. And I think particularly for high-profile stocks, no one is forgetting about them. And so there will always be some desired scheduled review of the management procedure, if not confrontation of the management procedure with other information maybe coming from a stock assessment. Thanks.
Our next question: if you drop models from the grid because they are not important now, they might become important in future iterations and you won't see it if those models are dropped. Do you have to frequently revisit the grid or just carry everything forward?
Yeah, that can be part of the management procedure review. You continually get updated data. You can use that information to determine whether the grid is still meaningful or representative of the uncertainties you're experiencing. And again, that happens on the order of every 6 to 8 years or something. John, go ahead.
No, I think no, you answered it great.
Okay. And our next question is: do you have any suggestions how to balance the necessity to bring everyone up to a common understanding and respecting the amount of time stakeholders have?
I think some suggestions are start at the end in terms of what you're trying to get stakeholders to provide to the process. And if they don't need a common understanding of all parts of it, then maybe they don't. If it is going to come down to a key decision point before them, remembering who those different stakeholders are, then try to use an intermediary group who might be able to stay part of the process and tell, like someone who might just need to weigh in, can you buy this trade-off between allocations? They may not need to know everything else about it because the one thing they care about is the allocation. And I think trying to be cognizant that too much information risks stakeholder fatigue, risks the process, I think, falling apart, and high grading that participation to where they fit into it. Because we found that people often want to open up everything under the sun at times, and that may not even be part of the process to do that, particularly if there's new science and there's other hypotheses out there that really aren't germane to the question at hand. Like if it was, for instance, developing a harvest control rule, that may not mean that we open up every single uncertainty to under the sun to answer the question of, can we get a pretty good harvest control rule?
Thank you, everyone who submitted questions for us. Thank you for sharing your work with us today, Cassidy and John, and thank you, BI, for organizing this event. Audience, please join us again on April 3rd at 3 p.m. Eastern Standard Time for the next National Stock Assessment Science Seminar. Take care and enjoy the rest of your day.